This is just a directed readings and research course. So I do want to thank Dr. Merritt, who's guided me through the research process and has turned into this work that I've done. Spindle whorls provide an excellent means by which to examine textile production, since in the archaeological record, as we know, plant and animal fiber often doesn't preserve well. So I wanted to study through experimental archaeology the interrelationship between spindle whorl morphology and yarn production. And through my research, I found that a lot of articles do say that whorl weight, and you can see the whorl is, this one is the top, it's the circular disc at the top. They do say that the whorl weight dictates the type of yarn produced. And it's often published in archaeological articles that this is an assumed relationship, and it's applied to textile production analysis and estimations. So I spun on the 66-gram top whorl that was in the picture in the last slide, and I tested both merino top whorl that had 19 microns in diameter and a crossbreed wool that was 33 microns in diameter. So, oops. Let's back, okay. So if you know, those are actually fairly significantly different sized fibers to be working with, and they were both industrial process, so they were combed and ready for spinning. My goal was to achieve a worsted weight yarn and a fingering weight yarn, and if you're a knitter, you know that those are very different thicknesses that you're working with. And just to show, so I wanted to show that you can produce different sizes of yarns with the same spindle whorl weight. And to measure this, you wrap yarn around the surface of an item, and the wraps per inch, which is you measure, and that tells you what kind it is. So you can see that the fingering weight must be 19 to 22 wraps per inch, and worsted weight is 9 to 11 wraps per inch, and those are pretty standard sort of sizes. So my observations, so you can see those are my two samples of boards that had fingering and worsted weights, and I showed that whorl weight is not indicative of yarn type. To achieve different yarn thicknesses, I found that drafting the appropriate amount of fiber was the key part to it. And I did find that both the crossbreed wool and the merino wool spun fairly easily into these two different sizes. And admitting I'm a fairly novice spinner, so I'm not one of these people who are doing it as their as their life job, which is interesting because spinning was a big part of textile production, and actually textile production was one of the most labor-intensive processes committed in the past. So as I said, I've shown that whorl weight is not indicative, and so I believe that this research is valuable and contributes to material culture analysis when you're looking at textile production, because it shows that the assumed relationship between whorl weight and yarn thickness is not as accurate as it's seemingly said to be. And I've noted that there's possibilities of expanding the research by testing different fibers, specifically testing fibers like cotton or flax, because I just worked with two different wools, so this could be expanded to different regions in the world. And maybe trying the same experiment with a lighter whorl to see if I can produce similar results in using a lighter whorl. And then lastly, by questioning the validity of basing yarn thicknesses on whorl weights, I've shown that the spinner has a lot of impact on yarn diameter, and my goal is to change the conversation on spindle whorl analysis in the archaeological record. So thank you.